Hello, this is Questionnaire by Jobo. It is pretty interesting. It is, I think, a take on the Whispers variant. So let us look at it then. Normal Sudoku rules apply. Digits on a line must differ by at least. So normal Sudoku relies digits 1 to 9 every row, every column, and every 3x3 box. Digits on a line must differ by at least the number given in the first column of the corresponding row. So for example, this line over here has a 3 in the first column of its row, and so digits along a line, each digit has to differ by at least 3. So something like this. Digits separated by an x must sum to 10. So these two digits sum to 10, these two digits sum to 10. Not all x are given. Cells in the same position within two 3x3 boxes. Okay, so this is disjoint sets rule, which is going to be probably the toughest one to, spot. Cells in the same position within two 3x3 boxes cannot contain the same digit. So for each box you have, these digits that are in the same position of each box. Now those digits cannot contain repeated digits, so you couldn't have a 1 here because these two break. They see each other by the disjoint set rule. So with that, let us begin solving. So obviously I can put a 9 here to finish the column, but that's not going to give us much. We can look at the 8 and the 7. I think those are more important, because these two digits must differ by 8, and the only two digits that differ by 8 are 1 and 9. Any other digits do not work. What about 6? Oh, sorry, 7. Well, you could have 2, 9 or 1, 8. So there are multiple options for that. And it's possible they could be 2, 8 if this is 2 and this is 8. So yeah, okay, I see. So what about this 6 then? Well, you need 3 different digits. I think the 5, 6, 7, and 8 we can all say must have opposing polarities. And what I mean by polarity is, from the 5 you can have digits that are lower than 5 and digits that are higher than 5. And for the 5, 6, 7, and 8, you can never choose 2 digits from the same polarity that are differing by at least these values. So 2 digits here cannot differ by at least 6 if you choose the same polarity, and therefore must be from different polarities. They also cannot include 5, and the reason why is because if you place a 5 here, these digits can never be 5 away from it, and same for all of these cells. So you can basically say that none of these are 5s. That's probably useful somehow. I could do something with this maybe. But what are possible pairs for here that differ by at least 6? You could have 1, 7, 2, 8, and 3, 9. Oh, those are the pairs that differ by 6. But it could differ by more than 6 because it's at least in the rules. That's at least the number given. So what we're saying is that this not only must have something that differs by 6, must also have something that differs by more than 6. Because if they both differed by 6, then they would have equal digits on the outside of the line. I mean, it doesn't have to differ by 6, right? It just has to differ by at least 6. So technically speaking, they could differ by 7 or 8, and it would still be fine. Okay, fair enough. I mean, this doesn't actually help, does it? Because those digits are always different, and if those digits are different, they will differ by at least 1, no matter what you do. So, okay. I don't see what to do here then. Might have to use the disjoint rule set on this line of digits here, where this line, well, it sees those cells, but we already know it's 1 or 9. What about this digit? That digit is here. Okay, well let's look at our options then. We have 1, 8, and 2, 9. Because it'll be 1, 9 itself. This 8 means this can't be 8. So this can't be 2. If this was 2, well I mean by this joint set it can't be 2. But if this was 2, this would have to be... Oh, this could be 9. But we know by this joint set it can't be 2. So, there you go. Okay, well this is not shaping up to be very fruitful. What about this digit? Can't be 1, 4, or 6. But then what? Well, if this can't be 1, maybe that says something. A 2 would have to be beside 8 and 9, right? Oh, but it could be 9, I think. Well, what if it was a 9? Let's think about what if it was a 9. If it was a 9, you'd have 1 and 8 here. Does that break? No, because this could be 9 and then 1. And then these digits could be 1 and 2. Oh, but none of them can be 1 anymore. So then... Oh, they could be 2 and 3. So it could be 9. I'm just wondering... Sorry. I'm gonna put all of these back first. I was saying this can't be 1 because of this joint set. If it was a 2 though, it would have to be next to 7... sorry, it would have to be next to 8 and 9, right? Yeah, it would have to be next to 8 and 9. I think that might break though. Would that break? Because whichever was 9 would see one of those cells, forcing that to be a 9 on one of those cells, which then removes 9 from those cells completely. Which would then have to be 1 and 8, right? Because you can't have 2, 9 anymore. Because 9 is no longer in these cells. And then 1, 8 has to be 1, 8 like this. Which does that break? 1, 8, no it doesn't, because you have 1, 8 and then like 9, 1, 9, 8 here, and I think that will be fine. So 2 works. A 3 doesn't work because a 3 can only be next to a 9 and 3 in the middle doesn't work. 8 would be next to 1 and 2. So an 8 here would have to be next to 1 and 2, which well, whichever one is here, this will have to be 1. So this can't have a 1 in it if it's an 8, and therefore has to be 2 and 9, which has to be 2, 9 like this, which force a 1 here. That might be interesting, but that's only this only happens if it's a 2, 8. If it's a 9, we know it can't be 1 anymore. Then it would have to be 2, 3. Okay, so I think we could look at some stuff here. If this is a 2, the outsides must be 8 and 9. If it's an 8, the outsides must be 1 and 2. And if it's 9, the outsides must be 2 and 3. So a lot of options, but I don't know if that's useful then. Yeah, it doesn't seem very useful at all. There must be some other way to break in. Maybe like here or something. But the issue with these numbers are that for this number, every number has at least 2 partners, right? This is your normal German whisper rule set. This is your normal Dutch whisper rule set. I don't know where I can say that must there be a 1 in these cells and must there be a 9 in these cells. I mean, yeah, there must be a 1 in one of these cells. That's same for 9s. So those can't be a 1, 9. Those can be 1, 9 pairs. This could be 9, 1. This could be 1, 9. I'm like, there has to be one in one of those. One in one of those cells. But if there had to be a 1 in one of those cells, I mean, this could also still be 1, 9, could it? Because you could have... Well, I don't know if this can still be 1, 9 then. I don't know if this can still be 1, 9. And the reason for that is, if it was 1, 9, then none of these can be 9. That can't be 1 or 9. And then this can't be 1 or 9 either, because you have 1, 9 pairs everywhere. And then this wouldn't work, right? Because you need a... If this is a 2, then you need a 3 somewhere on the sides. And in fact, this is a 2, 3, 8 pair. If this is an 8, then you need a 3 somewhere here, which is only 5 away. So this can't be 1, 9, and therefore would have to differ by exactly 7, because it can't differ by 8. So again, it's either 1, 8 or 2, 9. Oh, but then that means this can't be 1, because this can't be 8. So that can't be 1, and this I think can't be 9, because this can't be 1. Wait, why did I remove... Yeah, and this can't be 2. So this can't be 9 because this couldn't be 1 or 2. So yeah, this can't be 9, that can't be 1. Okay. So a little bit more something here. I guess I can mark that as having a low digit, that as a high digit. Again, not very sure if that helps, but... Okay. In what case is there a 3 here? If it was a 9 there. How'd that break? If there was a 9 there, you'd have 8, 1, 9, 1, and then 9 here, and then you could have 2 and 3 on the outside, which is fine. If this is 2, 8, well, the 8 would have to be next to... Oh. Well, if this is 2, 8, then this just can't be 8. But if it's 8, it has to be next to 2 and 1, right? Yeah, that doesn't work. If it's an 8, well, no, it would work, because 8 would be next to 2 and 1. This is a 1, 2 pair, which I think automatically resolves everything. 1, 2 pair, that would be a 9, 1, 2, 1, 2, and then 9. Yeah, and then this... Oh, whoa! Oh, I didn't even see that. Look at that. I didn't even... Yeah, this 9 just sees that by this joint. Okay, fine. So that's 8. Which means this must be a 1. Okay. Okay. So now let's think about where 9 has to be next to. 9 has to be next to 2 and 3, because we know there are no 1s here. Therefore 2 doesn't work, because 2 would have to be next to... Well, 2 could be next to 8 and 9 if you had 8 here and 9 here. But I don't think this can be an 8 then. If it's 8, then this must be 2, which means this must be 9, which doesn't work. So you kind of have this... Yeah, this 8 here also sees that, so... Okay, well, we have something. And we have 5s. 5s cannot appear on X's because the other digit wouldn't be 5. 5 can appear there. 5 is one of those 2 cells in this box then. And then we have 5, 2, 3, 5, 8. Yeah. I think I can do that. I don't know. But this would then have to be 8, 7, or 2. Which I think is fine. But doesn't really tell us much. This might have some effect on this though. Because if it was a 9, it would be next to 2 and 3. If it's a 2, it's next to 8 and 9. And therefore there's always a 2 in one of these 3 cells, which means this will never be a 2. So that can never be an 8. Yeah, so we've identified 2 possible states, correct? Yeah, 9, 2, 3, 2, 8, 9. Which means this could still be 3 or 8. In fact, that forms a 2, 3, 8, 9 quadruple here, which means the last few digits are 1, 4, 5, 7. And I'll be marking those down, because I will. Okay, so now 5 is one of those cells, because we know that 5 is in one of those cells which sees those. So 5 is in one of those cells. What does that mean? 5 near the 3 might be interesting, because that can only be next to... Or that could be next to 1, 2, 8, and 9. which would form a quadruple here. Or in fact, it would form a pair. Sorry, a 2-9 pair. Because these two are not even. Okay, that's interesting. But ultimately, I don't think it really does anything, because 5 here could, you know, it could just be there. In fact, this line doesn't do anything at all. Okay. So 9 is in one of those cells. What does that mean? 9 is not in one of those cells. Then what? I don't know. Maybe the 5 here. Does it see anything important? Oh, wait a minute. I think I've broken the puzzle then. Oh, you know why? I did everything wrong. Hold on. That's not... This is not... Okay, hold on. This is not even a 2-3. Yeah, this 8 sees that cell. What am I doing? So therefore, this can't be a 2, right? Because a 2 needs to be next to 8 and 9. And this can't be 8 or 9. So this must be 9, which is next to 2 and 3. Right. Why did I make this a 2, 3, 5, 8? No, this is a 2, 3, 4, 5. Sorry, and this can't be 5. So this is 2, 3, 4, 5 quadruple. This is a 2, 3, 4. Well, that must then be a 4 then, because 2 and 3 are already used up. So that's 4. That's 6 to complete the X clue. 2, 3, 5. Okay. So this now can't be a 6, 4 pair. It could still be a lot of things though, yeah. Okay, well that was a huge mistake on my part. I was thinking that because like, what are these digits now? They're 1, 5, 7, 8. But this can't be 1 or 8. So it's 5 or 7. Okay. So that works. I think those are higher numbers, and we already had a lot of trouble with the higher numbers. So I think the lower numbers are going to be even worse. Because, like, what? This is a really short German whisper. And if you didn't already know, digits that differ, a line with digits differing by at least 5, that's called a German whisper. If it's 4, it's a Dutch whisper. And I think there's a third variant, which is like at most 2. Digits along a line must differ by at most 2. And I think that's called a Chinese whisper. I don't know though. I think I've seen it somewhere. But okay. Now what? We could probably play with some disjoint sets. Like this 4 not being able to be like here or something. Yeah, that probably isn't it. Actually, I want to say that whatever this digit is, can't be in those cells, it must be there. In one of those cells. And same for 1 actually. So 1 can't be in those cells, and that must be one of those cells. So this cell either has this cell has the 1 in it, but it also has whatever this cell is, right? Because it isn't there, it must be here. So these cells are 1, 2, and 3. Therefore this cell is either 7, 8, or 9. But this cell and that cell must be different because they're in the same sort of position within a box. Is this a 1, 2, 3, 5 quadruple? It is. So this is 7, 8, or 9. Which means that these cells, well, I don't know what those cells are. But I think those are 2, 3, 7, 8. Yeah, in fact, I could just tell you what those digits are right now. Those digits are 4, 5, and 6. Okay, so maybe that's useful. Because they're all on the start of a line, right? What about here? What if that was something? Well, because we know this is... Yeah, if this is a 5, we can't have 1, 8, or 9 here. That will have to be a 2. If this was a 4... If this is a 4, this must be a 7, right? Because it can't be a 1, 8, or 9. If this is a 6, then this can't be 9. It could be 2... Oh, but it can't be 3. And it can't be 1. So if it's a 5, it can't be 1, 8, or 9, so it's 2. If it's 4, it can't be 1, 8, or 9, so it would be 7. And if it's a 5, then it can't be... Oh, sorry, if it's a 6, it can't be 1, 3, or 9, making it a 2. So this cell is either 2 or 7. Which I can't resolve by disjoint sets. No. That's unfortunate. I'll say... Sorry, 4 and 5 are with 7, right? 6 is with 2. Wait, 5 is not with 7. 5 is with 2, sorry. 4 is with 7. 5 and 6 are with 2. Okay. Well, I don't know how that helps. I can't do the same with 2. 2s are even worse. In terms of whatever they're talking about. 2s are even worse. And this cell sees those cells, but none of them are 2 or 7, so I can't disambiguate that at all. Sees that cell though. What does that mean? I don't know what that means. Okay, well 6 can't be on the line. This cell can't be 4 either actually. And the idea is that can this be 4? If that's 4, I mean it could be. And yeah, and the idea is if 4 and 6 are on the German whisper line, it can't be at the end. Because 4 and 6 only have one possible partner. Oh, sorry. 4 and 6 only have a partner. Only have one partner, which must be 9 and 1 respectively. And therefore they can't be in the center. Because they have to be with 2 different digits. Which doesn't work. Okay, hold on here. Sorry, a little bit of rambling outside. But what I was saying is that 4 and 6, if they were on the line, must be at the ends. But obviously 6 can't even be on the line at all. And if 4 was on the line, it can't be there. It would have to be there if it was on the line. It doesn't have to be on the line because it could be in these cells. So yeah. Don't know what that means. We also don't have a lot of digits. So can you tell what digit this is? It can't be a 1. It could be a 2. It can't be a 3. It can't be a 4 because 4 can't be in the middle. It can't be 5. It can't be 6. It can't be 8 or 9. So this is also either 2 or 7, isn't it? Because it can't be 1. It could be 2. Can't be 3. Can't be 4. Can't be 5. Can't be 6. Could be 7. Can't be 8. Can't be 9. So this is either 2 or 7, which does form another pair. That is weird. But 2 and 7 are actually on opposing parities, so I can't do anything about that either. Now, does 2... How many partners does 2 have? 2 can be next to 7, 8, or 9. While 7 could be next to 1 or 2 only. If 7 was next to 1 or 2, you would need a 2 here and a 1 there. But I think that's okay. And if it were 2, well, this would be from 7, 8, 9. But I think that's a little bit harder to disambiguate. Yeah. Okay, so now let's see. We have a 2-7 pair, which means I can tell what the rest of those digits are. 3, 4, 5, and 6. And I guess by disjoint, we can remove a bunch of these options. 6 here. Oh, these can't be 6 as well. They can't be 4 or 6. Which means that forms a 3-5 pair. So now this can be 3 or 5, which forms a 4-6 pair. Ooh, and that looks very interesting because a 5 here removes all possible candidates. A 5 here doesn't work because 5 and 4 are not 2 apart. 5 and 6 are not 2 apart. So this can be 5. That's a 4-6 pair. This one I don't really care because, you know, we could put anything there. Whatever. That's a 4 or a 6. Wait, sorry, what was I looking at? These cells by disjoint are not affected at all, I don't think. Although they do see that cell specifically, which can't be a 5 anymore, interestingly enough. Because they're in the same position, which means that there's a 5 in one of them. So this can never be 5. How does that even do anything though? 4-6 pair here sees anything? Don't think so. But at least we see some sort of disjoint. We see some sort of disjoint synergy here, where these two cells forming the pair are in fact in the same position in each box, which means that it also helps in terms of the disjoint set in saying that, well, this can be 2 or 7, perhaps, if that ever becomes useful. Now let's think about what happens if this is a 5 then. Yes, if it's a 5, it will have to be next to 1 and 9. Those are the only 2 digits, but that doesn't work because this 1 and this 9 mean that this doesn't have any possible digits. So this can't be 5 and it must be a 3. Ooh, giving us some digits. So this can't be 5, meaning 5 in here must be there. So this must be at least 3 away, which therefore must be a 2. Therefore that is a 7, which is a high digit. A 7 again must be next to 1 and 2 only, which we can resolve. So that's 2, that's 1. This 2 resolves the 3 and the 2 here. That's 3, that's 2. This digit must be 5 away. Can't be 6 or 7, so this digit is either 8 or 9. But by disjoint, this 9 here means that can't be 9, so that's 8. Cool. This means that now can't be 2. So this is a 1-3 pair, which means that this is not 3. I mean, we could have told by that 3 over there. Any disjoint? Any sneaky disjoint sets? I don't think so. That cannot be an 8 though, because it's not a 2 on the opposite side. This 1 could be useful, and in fact this 8 could also be useful in determining disjoint sets. But I don't think so. Okay, I can tell what those digits. Oh, this 3 actually resolves that, so that's 1. That's 3, therefore that's 9. Cool. Here we have 7 and 8, I think. And these must differ by... Oh, they must be... So any digit here would work with the 3. Unless there's some disjoint set I'm not seeing. No, I don't think there is any disjoint set I'm not seeing. So this could be either. Because 3 is in fact 4 away from both 7 and 8. Okay. Well, a 1 in this box we can place, because 1 here sees those cells, and by disjoint set, this 1 here sees that cell, so 1 goes there, which works because this is fine. This has to be at least a 4, but it could be anywhere above 4, so it could be like 4, 7 or 8. Yeah, and then these digits could be anything as well, because they just have to be greater than 1 by these 2. Okay. This 1 here removes 1 from that cell, which means that because we have like 6 1s already, right, the remaining 1s have to occupy which cells in the box. Maybe I could put 1 in this cell, because these 1s see those cells. By disjoint set, this 1 sees that cell, and nothing else. Wait, so actually where does 1 go in the remaining 3 positions? 3, 1, 2. Oh, they would go here and here and there. Right, those are the 3 remaining positions for 1. But these 2 cells cannot be where 1 is because 1 sees that. So therefore, actually, by disjoint set, I can say that there must be a 1 in this position somewhere in the board. There must be a 1 in this position somewhere in the board. There must be a 1 somewhere in this position in the board. but it cannot be here or here. It cannot be any of those cells. So where is the 1 in this position? It must be here. I think I can say that. Which means that one of these cells are 1 and one of those cells are 1. I guess we could... Yeah, I guess we could have also used an X-wing idea here where all these ones see all those cells, and then this one sees both of those cells, which places an X-wing here, which then sees those cells, which means now those are 1s, and then 1 goes there. So by X-wing you could also prove a 1 goes there. So that's fair enough. Okay, well that's enough disjoint sets for today. I don't think I should be looking at that anymore. Where next? This maybe. Because this must differ by at least 4 and can't be 8 or 7, so it must be 9. 6 doesn't work, it's too small. Now this must differ by at least 3, which means it has to be 6 and below, but it can't be 1 or 3. By disjoint set, nothing else sees it by disjoint set. So it could be 2, 5 or 6 I think. Can't be 4. 2, 5 or 6? But 6 doesn't work, does it? Well, 6 should work, because 6 can be beside a 2 here. So maybe we have to do this again where we look at the options for this. If it's a 2, then this will have to be at least 5. So it could be a 5, 6, 7 or 8. But it can't be 6. It could be 5, 7 or 8. So that's already a lot of options for one single digit. Fair enough. What digit have we not seen here? This is a 2, 4, 5 or 6. I guess I'll put it down. Whoa, 2, 4, 5, 6. This 2 means that can't be 2. In fact, this 2... Oh no, it doesn't see anything. No, I was like, does it see that? No, it doesn't. That cell sees that though. So 2 is in one of those cells, which we probably already know. This cell sees... Well, it sees stuff, but doesn't see enough. Doesn't see a lot at all. And this cell... No, this cell... No, this cell also doesn't see anything. Right? Yeah, it doesn't see anything. I was like, this cell maybe? But no, it doesn't see anything either. Okay. Well, I can probably just do more regular Sudoku then. So this is 3, 4, or 9. But this 9 and this 9 remove 9 from those cells by this joint set. So that goes there. Anybody distinguish the 3, 4? Not right now. I feel like disjoint sets make this puzzle a lot more 3-dimensional. In that you're basically like stacking each of these up into forming another 3x3 square. So besides your regular, besides your regular 1D lines and your 2D squares here, you sort of this third dimension over here where like the entire puzzle is stacked on itself. What am I doing? Where the puzzle is stacked on itself. So you kind of have each of these 3 layers sort of stacked on top of each other, and then these all form a single square, I think. I don't know, but yeah, it feels 3-dimensional. Okay, well, what was I doing? Oh, sorry, this 9 has to be 4 away, not 3 away. Why did I say 3 away? So this can't be a 6 then. So it's either 2 or 5. Because it has to be 5 or less, but can't be 1, 4, or 3. Okay. That is something. So again, let's actually just look at this again. If this is 2, it has to be at least a 6. But it can't be 6 by disjoint. It can't be 9, so it's either a 7 or an 8. If it's a 2. If it's a 5, or if it's a 5, it doesn't work because 5 needs to be next to 2, 9 and 1. And this cell can't be 1. So this can't be 5, so that's just 2. Ah, so this is a 7, 8 pair, which means that those digits remaining are 5 and 6. Which, maybe we can disambiguate? Just kidding, we can't disambiguate that. Okay, fair enough. This digit, can we disambiguate that? No, but it does form... Ah, woo, okay. So all these digits are actually a set of 1 to 9 by disjoint. And this is a 7-8 pair here. So I think I might as well just color this. And in fact, should I color that? Should I use colors to make this a little bit more easier to spot? I think I might do that. It's super late into the solve already, but I think I will do that. So if you'll just give me a second here, I will color everything in. And hopefully it doesn't affect the colorblind people. It's just easier for me to see. I don't know if this obscures the line as well. That could be a potential issue. But honestly, it can't be helped if I have to use 9 different colors for this. So I'm gonna be doing that. And then I'll be right back. Yeah, you see this set is almost complete already. I'm just gonna use gray for that. And then the last few I'm just gonna plop in the standard rest of the colors. So like a pink here. That differs with purple by quite a little bit. I don't know if it's enough. And then I guess blue, light blue. Yeah, okay, you can tell. Okay, so I can just do this, yeah, okay, and all of these will color up. Okay, that works. That is actually very helpful. So here, we actually have almost all the digits from 1 to 9. The only digit that is missing is a 2, which must therefore be there. See? Useful. Now the gray digits. Oh, okay. Whoa. Wait. Oh, because I need to be in color mode, sorry. I need to be in color mode, and then all the colors show up. So those digits are almost finished. We therefore need I think 4 and 6 to finish us off, which is fine. Okay, what else do we have? Could do a little bit of... We don't have a 3 here yet, so one of these cells are a 3. Okay, fair enough. That is not even close to finishing. This, we can put down the last 3 digits, and in fact we can do that by column also. So those digits are 1, 3, and 5. This can't be 1. This can't be 5 by the 4, 5, 6 triple here. And it can't be 3 by that cell, so this is just a 1 then. This is 3 or 5. And I don't know if we can disambiguate that. I don't think we can. Okay, fair enough. Okay, what next? Those digits? Not sure. Can I put those digits in? Oh yeah, in fact one in this box is just there. Which doesn't really help because that could be anything. That could even be 3 and that's technically valid. Well, I mean it's not technically, it is just valid. So those digits are now 2, 7, and 8. But if we look at the colors, 2 can go there, 2 can go there. Okay, fine. Here might be finishing up because we have 3, 4, 6, and 7. I don't think we know what that is. Six can't be in any of those 2 cells here. So 6 has to be one of those 2 cells. Which means what? Don't know what it means. But okay, see, look at this. We're basically done with all the lines, right? So that just means that, well, basically the only line we're not done is with that. Okay, 6. 6 is next to 4 already. Oh, it could be next to 3 as well. Oh, it can't be next to 3 actually because of that 3. So if this was 6, it can't be next to 1, 2, 3, or 4. It can't be next to 5 or 7 because those are not. There can't be 9, so it would have to be 8 if it was 6. Which is possible by disjoint sets, that's fine. If this is a 4, it can't be next to 1 or 2. It can't be next to 3 because it's not 1 away. It's only one away. It can't be next to 5 for the same reason. It can't be next to 6. It can't be next to 9. So it could be a 7 next to a 7, which is allowed by this joint as well. So this is either 7 or 8, which forms, or would you look at that, another pair. So those digits are 3, 5, and 9. Which what? Well, this can't be 5. But, I mean, that isn't necessarily a triple at all. So we don't have much to work with. But I think it's at least okay to put some digits in. Well, this is a 7, 8. Wait, oh, so 7 can be next to 9 here. So this could be 9. It could also be 3 if that was 5, that's also fine. Because those are differing by at least 2. And I think these 3 system of pairs and triples are isolated from each other. So they really don't have to do anything special. Yeah. 4, 5. We don't have a 9 in this set yet. So 9 is one of those cells. But that doesn't really do anything for us. Here we've basically finished it. This one we've basically finished as well. I think the ones we have actually finished is... Which one? This green set is almost done, basically. Yeah, I think this is just something to just... I don't know actually, I don't know. What are the remaining digits here? I think I should check that. 4, 6, 7, 8. Right? And these cells kind of have 6 in them. So 4 will need to be next to, well, actually 6 doesn't work here, does it? Because 6 isn't at least 3 away from any of these cells. So this can't be 6. So that's 4. So that's 6. So that's 4. Sorry, that's 6. This now can't be 4. This now can't be 4. That forms a 7, 8 pair. This 6 resolves this 5, 6 pair. So that can't be 5 now. Therefore 5 here must be here, which means it must be next to... Well, we don't know. It could be next to 3 or 9. I think both work. This must now be 3. Which doesn't seem to do anything. No. Well, we could probably do more of this shenanigans now. Because we have 6. The remaining digits are 3, 4, and 7. But this can't be 3. This could be anything. So that's funny. Here, what are we missing? We're missing a 3. But any of these could be 3, I think. We haven't figured that out yet. Yeah. Okay. And this is a 4, 6 pair. This one is just done. Okay, I think it's time to just look at the board for a bit. Maybe stop looking at this disjoint sets for and just stare and see what I can do. Like this 7, 8 pair. That's very interesting. But no, 7 could be here or there. This 9 could again be next to 7. This 3 could be next to anything. 6 could be next to 8. But the issue is that 6 making this an 8 makes this a 3. So you can't have this be 6 and 9 at the same time. So what? I don't know what. Okay, let's look at this again. The 3, 9 is separate of itself. The 1 is separate. 2, 4, 5, 6, 7, 8 are remaining here, which all appear, so nothing seems to be very forced. Yeah, nothing seems to be very forced. Okay, I really gotta make sure I don't miss anything. like 3 and 9, yeah, they're there. 6 can't be there. 6 could be there though. And then 7 and 8 can't be here, but 7 and 8 could be there. And in fact must be there along with this one. Whichever, yeah. Okay, I don't know. Maybe I'll just mark these in. Oh yeah, where does 5 go in this set? This 5 removes 5 from all those cells, so 5 must go there. Okay. 5, 7, 8. This is 7, which works. That's 8, 7. Okay, we're getting a lot more digits now. Hopefully this helps us finish up the rest of the puzzle. Or maybe it just will leave me stuck here again, because I can't see this. What's a good place to just pick off? Oh, we don't have any good places to pick off. Dang it. Okay, back to colors. Those digits are now 3, 7, 8 to finish off this section, which means that the remaining digits must be 4, 6, 9. This can't be 6. Sorry, this can't be 6. This could be anything. Again, this line really does not matter because digits already differ by at least 1, so whatever. Yeah, this has to be 4, 6, 9. That does work. That is very messed up. This one, well, I mean, we have a digit. We have a new digit. So the remaining digits are 2, 4, 5, 6, 8. Oh, but where does 8 go? 8 can't appear in any of those cells, and therefore can't be any of those cells as well. Therefore 8 must be here. So that's 8. So that's 8. That's 2. This 8 does not help. There's 2. This 2 places a 2 here in this box. This is 4, 7, and 9. 9 can't be there, so 9 goes up there. Which means what? Well, this 2 removes 2 from that cell, so that's 5, that's 2. Okay. So this is not 5 anymore, meaning 5 must be there. This must be 4, 6 to finish off the yellows. So this is 4, 6. Oh, sorry, this is 4 or 6. This I think is also 4 or 6 to finish off the dark blues. This 7, 8 pair removes 7 from that cell, so that's 4. That's 7. This 4 sees that, so that's 3. That's 4. This 4 sees that, so that's 9. That's 3. That's 9. So this has to be 7. So that has to be a 4. So that has to be 6. And we are cooking with gas. 6, 4. This, well, this is not 4, 7, that's 3. So this must be 6. This is not 7, so that's 8. That's 7. This is 8. So that's 3. So that's 7. So that's 4. That's 8. And the last digit here has to be 5. Solving the puzzle. Hey, well, this was nice. Yeah. A lot of interesting ideas between disjoint sets. I think it was a really good idea to color everything in, because that allowed me to see a lot better. So I'm going to go back to color mode here. Yeah. Every one of these sets are now disjoint. They all each contain the digits 1 to 9. Yeah, coloring is always a good idea, just saying. You should always color when you think it's necessary. Alright, well with that, I hope you enjoyed this video. I will be seeing you now. Bye bye.